Chaos. How many people here have heard of chaos engineering? Okay, fair number of hands. Cool. How many people here are your ops engineers? Not so many ops engineers. Thank you, my friend. So I'm assuming the rest of you, how many of you developers? Okay, and the rest of you are maybe management, maybe something else? All right, see some people that are like, I don't know what I do at work, they just give me money. So for our lone ops engineer over there, or anybody else, maybe you're a software developer and you actually are responsible for your deployments, you're on call, you actually are part of the operations side of the software lifecycle. This is one of the things when we talk about DevOps, right? DevOps, Paulo is up here talking about delivery, but as anybody knows, your software gets delivered into production and it doesn't end there, right? We've all seen the DevOps loop, right? It looks like the infinity sign, or sometimes it's just a circle. But there's obviously a time after your software gets deployed where it's supposed to stay up and running, and it's supposed to provide your customers with value. And yet, oftentimes it doesn't. It crashes. This is my friend Corey. Corey and I worked together at Datadog for a while. Corey had this great quote that hope is not a strategy. You can't just hope that when you deploy your software, it'll stay up, or that when you provision some new AWS service or whatever cloud provider you're using, that it just stays up and running, right? We've all seen that AWS has gone down. There was a major S3 outage a couple years ago. If you're like, cool, screw it, Amazon, I'm going to go to Microsoft. Well, Microsoft had a major outage last year, so did Google. They all go down. Hope is not a strategy. And Corey learned this because Corey used to work at Netflix. And at Netflix, they had this same problem. They were moving from their own on-prem servers to the cloud, moving to Amazon. And they were discussing, what does that look like when you move to the cloud? How do you test this, right? When I have my own servers, there's a bunch of things that I can do to test my own reliability. When the cloud is literally just somebody else's computer, how do you test that? So they wrote up their learnings in a blog post that became famous. And it became famous because of something that they created out of it called Chaos Monkey. How many people have heard of Chaos Monkey? Yeah, that's pretty much everyone. And we've all heard this myth about Chaos Monkey, that it's this tool that randomly takes down servers and how it was this great thing. And I think most of us, at least myself, when I first heard of it, was like, that sounds like an awful thing. Like, what a horrible thing. Chaos Monkey was a thing. A lot of people get confused about what it is, so we'll dive into what that is. But who am I? So I did not work at Netflix. I'm Jason. I am now the Director of Advocacy at a company called Gremlin. As mentioned, I worked with Corey at Datadog. I made the transition to Gremlin in January. But yeah, formerly at Datadog, O'Reilly, MongoDB, a bunch of other companies. There's my contact info as well. I'm on Twitter. My DMs are open. If at any time you have questions, feel free to hit me up there or to send me an email. Also, as mentioned, I do work for Gremlin. Gremlin is a reliability company. We really strive to help people build reliable software, reliable systems, and reliable processes. And we do that by creating a chaos as a service platform. So allowing you to safely inject chaos. And we'll talk a bit more about that as well. That link up there will actually get you a free account on Gremlin, so you'll be able to play with chaos engineering after this. And we're actually going to do a live demo later if chaos doesn't get too out of control. But back to that Chaos Monkey, right? A lot of us, when we first heard of this Chaos Monkey and that it randomly destroys things, that sounded like a really bad idea. But if you were to actually take the time, go back to that blog post, which is, at this point, 9 years old, so it's been happening for a while, but they had some more information about it. And they said that by running Chaos Monkey, not at random times, but in the middle of a business day, in a carefully monitored environment, and with engineers standing by, right? So again, we're not doing this randomly, we're not just destroying things, we're actually having people there. Well, then the idea is that we can learn the lessons about our systems. And hopefully then, when things break on a 3 a.m. on Sunday night, we don't even notice. We can use what we learn to build more resilient systems, to have them auto-remediate themselves. So another great quote. This is Colton Andrews. He's the CEO and founder of Gremlin. He was actually working with Corey, and they were together on that team at Netflix. He was also at Amazon prior to the Chaos Monkey thing. But he has this great quote that chaos doesn't need to be random. Thoughtful, planned experiments are much more successful and a much simpler way to start. It's really easy to get started. And then probably the best quote of all, this is from me. If you learn anything at all from this talk, it's that you should not be a jerk. If you're breaking systems because you're like, hey, I wonder what this does, let's learn from it, and you decide to break systems, take down your infrastructure, harm other teams, then you're being a jerk. Please do not be a jerk. That said, let's dive into how we would actually do this, because I know you all want to start to embrace chaos. It actually is fun. And it's fun because one way that it is fun is it's a game. So we often call them game days. And just like any game, there are rules. Rules make games really fun, right? If I'm playing football and there's no rules, well then maybe I just punch the quarterback in the face and I steal the ball and I run and I do whatever I want and there's no points and so everybody wins, and that's not fun. So games have rules. Rules make it fun. The first rule, like any game, there's got to be a time limit. So we like to set it at 90 minutes. 90 minutes is a nice, small amount of time. Your boss won't complain that you're not getting work done because it's only 90 minutes. Makes it nice and concise. Of that 90 minutes, 30 minutes spent planning. You don't want to spend all your time planning. Nobody wants to spend days figuring out what they're going to do and have giant plans. Keep those nice and small. 30 minutes. 50 minutes playing. You want to spend the bulk of your time actually having fun, breaking things, learning about them. That's the joy of this. And then 10 minutes reporting, because again, who here likes writing up reports? Nobody. That's a good sign. I am in the right audience here. 10 minutes reporting. Don't spend too much time on this. The great thing is if you take good notes, if you're doing things correctly, it doesn't take too long to report it, because it's really just copy, paste, and email. Now, I like team sports. Teams are fun. You get to play with other people. You get to collaborate with them. So there is a team for your game. And the teams for this, at Datadog, we kept these nice and small because, again, you don't want your boss getting mad that the entire team is wasting a bunch of time. So with the teams, we generally kept it to 2 people. The first person was the subject matter expert. This is going to be one of your software developers, one of your infrastructure engineers, the person that built the system, that knows a lot about the system that you're going to be testing, right? So they know what's going on when you break things. They can have an understanding of how failure affects the software they wrote. The second is someone from the SRE team. And so for us, the SRE team wasn't the people that was there to be on call, so they just handled all the incidents. The SRE team is your experts in reliability. They're the people that know how to build reliable systems, and so they would partner up. And the great balance here is that your software engineer now knows how your system responds, and your SRE person can inform them and tell them how they can make their systems more reliable. Occasionally, we would have a third person, and that third person was a junior engineer or a junior developer. And the great thing about this is your junior engineer or your junior developer is fairly naive, right? They're new to the team. They don't know best practices that you've built up among your team, because your best practices often aren't necessarily industry best practices. They're often going to be team best practices because there are certain constraints that you operate under. And knowing those constraints is what makes people on your team experts. Knowing that we have to interface with this other system a certain way because it does some weird, funky thing. Or that little piece of code that looks like a complete hack and looks awful. Well, we built that because there was some other constraint that project management or some other team imposed on us. So your junior engineer is there to ask those stupid questions that aren't really stupid, that expose interesting bits of context. The other great reason that it's nice to have a junior developer is that now you can mentor them. If you're that senior engineer, if you're that SRE person, you can now inform that junior developer and help build up their skills. So I mentioned you spend 30 minutes planning. Planning should be pretty simple. First thing you have to do is schedule it. Just like those Netflix folks, you want to ensure that you're doing it in the middle of a business day when everybody's around, right? Because the idea here is random things when they break at 3 a.m., and that's horrible. But plan it for 3 p.m. when everybody's had lunch. Maybe you have an afternoon coffee or Coke or something to keep you awake, and you're just having a regular work day. Then you pick your tests. The tests, you start easy. So don't go crazy. If you're trying to break things, don't come up with these fantastical ideas of what if Amazon S3 goes down again, and at the same time all of my DNS breaks, and at the same time every single team deployed some horrible code and my CI pipeline's broken. Start super easy, and I'll get into the tests that we run in a bit. Then write down what you expect to happen. So treat this almost like a scientific experiment. Have a hypothesis. If I were to spike CPU on my server, what would happen? Would my application suddenly get slow? Would auto-scaling kick in? Start simple. Write down what you expect to happen. And then write down your plan B. Because as much as we try to make things safe, things could go horribly wrong. We all know that we work in complex systems. You pull one tiny little thread expecting not much to happen, and suddenly everything goes down, right? That was my first experience when I worked at Datadog. I was rolling out a very small change. It was just a change to some text within the Datadog application, and I broke all of our development environment. So write down your plan B, because small changes can have big effects, and you don't want to take out all of development, because then literally everybody in your company is sitting around trying to get work done while they're waiting for you. And finally, most importantly, you want to share this. Share it as wide as you can to your entire engineering organization, right? Not just your team, but to everybody that you can. Because, again, with complex systems, people are relying on your service. And if your service were to, for some reason, go down during this test, they need to know about it. They need to know what's going on. So we get to the actual game, right, when we play. Again, we want to start simply. And when we start simply, that means starting with a small blast radius and increasing it. So starting in staging, moving to production during off-peak, and then trying things during production in prime time. Similar to how you do any of your code, right? You start in development, you move it to staging, you move it to production. You want to do that with your tests as well. So treat your tests just like you would your code. Then you're going to announce things. Again, this is all about sharing information, so announce that you're starting your experiment. I always say that you should do this in a group chat, because you never know when somebody's out on a smoke break, someone's off to get coffee, maybe they're having a late lunch, and they don't miss it when you announce in the office that, hey, everyone, we're doing a game day. So put it into a chat, whether you're using Slack or whatever other tool you're using. That way people know what's going on. The other key thing is maintaining your discussions in that group chat. So again, if you're using Slack, that's a fantastic thing, because if I turn to my buddy next to me and I'm saying like, hey, this is what I'm seeing, here's what's going on in the experiment, the problem is none of that is recorded. And that means that when I go for that reporting, when I want to keep that reporting to 10 minutes, because that's the awful part that nobody wants to do, I have to recreate that dialogue in my head and put it down in that email. If I have it all in Slack, all I have to do is cut and paste. I love cut and paste. The fourth thing that you want to do here is monitor for outages. Again, do not be a jerk. Don't just break things and walk away. So you want to monitor for how your experiment is affecting other people. You also want to monitor for other people and what they're doing. If production is having an issue, if they're having an outage, the worst thing that you can be doing is contributing to that by having an experiment, right? So if things are going horribly wrong, if something's on fire, stop your experiment, let your colleagues resolve that issue, and then you can continue on once things are good. Finally, go out there, break things, have fun, and just be sure that you take notes. Any Mythbusters fans out there? I love Mythbusters. My favorite quote from Adam Savage is that playing around and like blowing things up is all fun, but if you like take notes, it's science. So yeah, be a scientist, just take notes when you're having fun. Now, as mentioned afterwards, the reporting, 10 minutes. You don't want to spend a whole lot of time on this. I know some people, like within Gremlin, our execs really love executive summaries, and so it takes a little bit longer. But at Datadog, we are all about efficiency. We just point people to the right place. So if there's things that need to be done, create the Jira tickets for those. Create whatever task management tool you've got, create cards for those. Because as we all know, if you don't create cards, nothing actually gets done. Then write that summary and key lessons. So that summary, again, should be super short. Just write down the difference, right? You've already emailed out what your plans were. So all you have to do is write that delta. These are the things that we saw that went according to plan or that didn't go according to plan. And that's pretty much it. So you can keep things really short. Again, the important part of all of this is sharing it. So email this out across your entire engineering organization because you want everybody to learn from what you're doing, right? We all build systems, and yes, they're slightly unique, but oftentimes we're building them in similar ways, and we're trying to learn from each other so other people can learn from the tests that you're doing. And then most importantly, celebrate. You should absolutely celebrate after you're doing this, which is why I mentioned doing it at like 3 p.m. is a great time, right? You do it at 3 p.m., you're doing that 90 minutes. That means you're ending at like 4:30, which means, hey, it's time for a beer. Go out and celebrate afterward. You celebrate because when you're doing chaos engineering experiments, you're learning. And so you're celebrating that you're learning. Imagine that I roll out something and it takes down all of production. Well, first thing, I don't go out and celebrate. I stop my experiment, I fix things. But then I celebrate. I celebrate because, wow, that takedown of production, it could have been much worse. It could have been at a time where I didn't have any colleagues around. It could have been 3 a.m., so I would have been sleepy and grumpy and really angry. But I did it during the middle of a business day, and I had colleagues around to help me, and we learned about this. And so we prevented that midnight outage or that 3 a.m. outage or that outage that would have happened on Black Friday, and we would have lost millions of dollars in sales. So that's a good reason to celebrate. Now imagine that you do an experiment and everything goes according to plan. Wow, like I totally crashed this server and another one automatically spun up and like my service respawned, all the traffic got redirected to it, everything went perfectly. Well, that's a fantastic reason to celebrate too, because congrats, you are a fantastic engineer. You built a piece of really reliable software. That's a fantastic reason to celebrate too. So celebrate after you do chaos engineering. Now, as mentioned, one of the key principles of chaos engineering is to start with very small tests. Start super easy and scale them up. At Datadog, we had a number of levels, and the first was really simple. Terminate your service, see if it restarts. Could be as simple as logging into your machine, SSH in there, find the process and kill it, right? Does it restart? It should restart automatically, but you'd be surprised how many times people write software and it needs some sort of manual intervention, some sort of authentication. You have to log into your secrets manager and manually plug in an environment variable or something like that. So start easy. Terminate it, see if it comes back. Also try to block one of the dependencies. At this point, it doesn't have to be resilient enough to survive. You just want to ensure that you're validating your hypothesis. For example, if I have a simple application and it relies on a database, what happens if I block that database? Well, maybe my application doesn't work, but at least my hypothesis should say that my monitoring should let me know that that database is down or unavailable. And my application should throw some sort of intelligent warning to me or my customers or whoever's using this, right? That's a perfectly valid hypothesis, and you just want to test that that's actually happening. The next level that we have is to block all of the dependencies. And again, your application doesn't have to survive this. It just has to have proper monitoring, proper errors, so that you know that this is going on, right? If I have an application that's a finance application and it's not receiving any transactions, that's okay, like, because it's completely blocked off, but I at least should know that, right? People in the company want to know when their finance application is not getting money. So have some good monitoring. The next level is we terminate the host. What happens when we take down the entire host? Does that host end up coming back if we're in the cloud? Do we have alerting on that? If the host comes back, does that service restart? Is traffic routed to it? Pretty basic. The third level is to degrade the environment. And this is really where I think the experiments become fun, right? Because you can try a whole lot of things. But this actually was a really good graduation point for us at Datadog. Because at Datadog, if you were a software engineer and you wrote a service, you were responsible for that service. That meant you were on call for it. So you would be in the on-call rotation. You would get woken up in the middle of the night if that software service failed. But at this point, when we degraded the environment, we were checking to ensure that there's proper monitoring and alerting on the service. So latency, errors, traffic, and saturation, what's often been called the 4 golden signals. Along with this, though, when we had those alerts, we wanted to ensure that there's proper runbooks, that the proper people were being notified, and that documentation was there. So if anybody got an alert, they would actually have all of the steps laid out of what they could do to troubleshoot. And they would know who they could escalate to. And the fantastic thing about this meant that if you were a software engineer and you had all of this in place, you could now call on the SRE team and put them into the rotation. Because at this point, if you have good alerting and it has a runbook, literally anybody should be able to get that alert, follow those steps, and do some basic troubleshooting, which means that those SRE guys, they don't have to know about your software. They just have to follow your playbook so you can get them on call. And congrats, that means you can sleep a lot better. After that, things got a bit more difficult. We'd spike traffic. So we would essentially run DDoS against our own systems, see how they responded. Again, doesn't always have to survive, but at this point, you have some pretty good assurances that your software should be doing okay. And then level 5. We didn't always get here, but at Datadog, we were multi-cloud. And so the goal here was always to see if we could be truly multi-cloud. If we decided that we were going to kill our AWS regions, would they actually respawn in Google or Azure? We didn't always get here, but that's always a good goal. All right, so who wants to live demo? Yeah. Let's see if this actually works, because Kubernetes was not really actually running, despite Docker Desktop saying that it was. Oh, let's go over here. And clear that. Who here is familiar with Kubernetes? Okay, a few hands. For those who aren't, Kubernetes is, I like to say, it's just fancy VMs. Containers have software in them, it's running. It actually manages, Kubernetes manages your containers, so if you kill one, it's supposed to restart them, and it spreads those workloads out over the entire cluster. So I've got Kubernetes running, and it's actually running a WordPress site, which hopefully comes up. Yay, it is actually running. So I've got this fantastic WordPress application. WordPress, for those who don't know, basic blogging platform. It's a Apache web server with a PHP application, and all the data is stored in MySQL. So pretty simple. That is my favorite park in Charlotte. That's Freedom Park. That's where we all go to play Pokemon. If you play Pokemon Go, that's where community days are. You should head there. Cool. So this is on the back end Kubernetes. You can see what we've got is pods. So I said kubectl get pods. Pods are essentially containers at this point. So each container is running an application. We can see that I've got Datadog for monitoring. I've got Gremlin to run some chaos. Here's my WordPress application. That's my PHP web application. And I've got MySQL. So how do we run experiments? Well, we first make things really big so that people can see them. So the before. We don't have 90 minutes, so I'm going to do this super quickly. We're scheduling it. It's happening now. Normally, you wouldn't want to do this. You'd actually want to give people a heads up. We're going to choose tests. Super basic application, WordPress, MySQL. We should kill one of them. Killing WordPress, Doesn't do much. You just get an error in the browser. So let's kill MySQL. How's that? So we're going to kill MySQL. Form a hypothesis. Any thoughts? If I were to kill MySQL on a WordPress blog, what do we expect to happen? Shout it out. 500 errors. I heard something from the back, too. No? Maybe that was the same. 500 errors. Cool. Maybe monitoring, we should see something. Yeah, I'm seeing some head nods. We'll say that monitoring should show MySQL down. Did someone else back there yell something? Should it restart on its own? Yeah, well, that's a good. Let's say that MySQL should restart. Yeah, because I am running in Kubernetes, so if I kill that pod, Kubernetes should notice that, hey, my pod is gone, and it should automatically restart that. Cool. Let me format this in Markdown and make that a list. Abort conditions and Plan B. So abort conditions, you always want to have abort conditions. If things go horribly wrong, what should you do? And you should have that Plan B as mentioned. This is just a presentation. So our abort conditions is if I take down my laptop and my laptop crashes. So I'm going to say if my laptop crashes, what's our Plan B? My Plan B is probably to go out and just grab another mimosa. That sounds like a great Plan B. And then finally, step 5, we're going to share this, right? So you've all now had this shared. I would normally email this out. Cool. So let's actually try this. So I've got, again, my web application here. There are a number of ways that you can do chaos. One of them, obviously, being Gremlin, since I work for them. But you can do chaos on your own, right? You can log into the machine. I can use kubectl to delete this pod. One of the reasons that I like Gremlin, and one of the reasons that I moved from Datadog to Gremlin, is I think they have a fantastic tool. They make it really easy for you to do this without having to install a bunch of tools, use command line, and they make it really easy to roll back. So I am working on containers here. I'm going to go ahead and search. Let's go ahead and make that bigger so folks can see that. How about that? All right, so I'm actually searching for MySQL. So I selected the tier MySQL. That's essentially a meta tag that I've got on this pod. We can see that I've got one container selected. And if I hover over that, it actually shows me, which is probably a little too small for folks in the back. From there, I can choose a Gremlin attack, and I can say shutdown. So the nice thing here is I don't have to worry about running any of these commands. I can really just point and click. I'm going to say no delay on that. I've turned off the reboot because I don't want the Gremlin agent to try to reboot this. I want to actually test if Kubernetes will do it. And then all I have to do is say run the attack. So I'm going to unleash that Gremlin. It's currently pending in my system. And while we do that, we can run back here. And I'm just going to refresh a bunch. Let's see. It's been distributed out. So essentially, the way that Gremlin works is you've got an agent, a little piece of software. You use the web UI to launch attacks. That informs your agent. That's going to actually do all of the commands. And again, the nice thing is it simplifies it. It also makes it standardized so that, oh, it actually ran. And my website's still up. Well, that's interesting. Did it actually run, you're thinking? So let's come back here. Kubectl, get pods. And we can see that my MySQL had one restart. So Kubernetes is really fantastic for things like this because Gremlin killed it. Kubernetes noticed practically instantaneously. We didn't see any downtime. So with that, I can simply come over here. Things we saw. We killed MySQL, and Kubernetes restarted it. Things we didn't expect, well, we expected that to happen. We can also check in our dashboarding if we wanted to. Let's go ahead and look at this for Kubernetes. See if this comes up. Did this actually... There were no network errors on the pod. Yeah, things look pretty good there. Cool. So from here, we would just continue to write this up. Things went as expected, right? Things went as expected. Things we should change or fix. Really nothing to do here. Cool. So, again, you want to ensure that you create JIRA tickets. There's nothing to do here because Kubernetes did its thing. It wasn't earlier, so I'm glad that it actually was. We would write a summary. The fantastic thing is we can copy-paste, right? So again, this is how you keep things nice and short. You have those 10 minutes to report. You share this. Congrats, you've all seen it. It's shared. And now we go out and we celebrate. So there are still mimosas. So as you saw, experiments can be really easy. You don't have to make it overly complex. Including sharing and planning in it doesn't take much time, so don't be a jerk. But that's really the gist of chaos engineering. It's not hard to do. You should all be doing it. It makes your software better. It helps you understand what's going on in your systems. It's really down to these three things. Plan it out. Have a plan. Start with something simple. Continue to escalate it up. Start in your dev environments. Progress to production. Share it. Share all the information. That's really the core of DevOps too, is sharing information so that we all get better. And then most importantly, have fun. A few additional resources. So I did show you Gremlin there. Again, you can use a bunch of other tools. I like Gremlin because it makes it easy. But if you're starting and you're starting simply, there's no reason that you can't use things like systemctl, kill, IP tables, right? You can easily kill processes. You can easily disable your network. One of the problems, though, with IP tables, don't lock yourself out. I've done that a number of times. Be careful with IP tables. StressNG for Linux systems is a fantastic tool. StressNG allows you to stress out CPU, stress out I/O, and it makes that fairly easy. But again, don't lock yourself out. It's pretty easy to kill systems and not have a way to get back into them. Comcast is a fantastic tool that we used at Datadog. Comcast allows you to simulate really bad networks. I don't know why it's named Comcast, like bad networks, but it's a great tool. Vegeta. Vegeta is a tool that allows you to do massive load testing. So it generates traffic. It's like if you've ever used Apache Benchmark or AB, it's like that on steroids. So it allows you to essentially DDoS your own systems. And then Gremlin. Obviously, like I said, I work for Gremlin, so grain of salt, but I really do like Gremlin. I've worked with them for far before I worked at Gremlin, and I really do enjoy their tool. So that link will get you a free Gremlin account where you can start to play with a bunch of the Gremlin tools. That said, that's it for me.